Unlike their copper-based counterparts, fiber optic cables use light to transmit data, offering significantly higher bandwidth and resistance to electromagnetic interference. They consist of one or more strands of glass or plastic fiber which are as thin as a human hair. These fibers are surrounded by a cladding layer that reflects light inward to avoid loss of signal and allow it to pass through bends in the cable. Light signals are transmitted in the form of pulses along the fiber's core via a transmitter. These light pulses represent the data, which can be anything from telephone conversations to internet content. Fiber optic cables end with plastic or metallic connectors that will be directly inserted into a network device or onto transceivers, which are then inserted into the devices. There are two main types of fiber optic cables: single-mode fiber, multi-mode fiber. Click each to learn more. This type of fiber has a small core, about 8 to 10 microns in diameter, and is designed to carry light directly down the fiber. It is used for long-distance communication because it has a higher bandwidth and can maintain the fidelity of each light pulse over longer distances without much signal loss. Select the next option. Multi-mode fiber has a larger core, about 50 to 100 microns in diameter, which allows multiple modes or rays of light to propagate through the fiber. Because of this, multi-mode fibers are used for shorter distances, as the multiple paths of light can lead to signal distortion and loss over long distances. Multi-mode fiber optic cables can be classified into OM 1 through 5. Click Next to continue. Computer and network equipment may not be able to interpret optical signals from fiber cables on their own. As such, transceivers are critical components in fiber optic communication systems. They serve as the interface between the fiber optic cable and the rest of the network. A transceiver has both a transmitter and a receiver in a single module, hence the name transceiver, transmitter plus receiver. Common types of transceivers include small form factor pluggable plus, which are gigabit interface converters or GBX, simplex and duplex. Click each to learn more. SPF transceivers are compact, hot pluggable devices used for telecommunications and data communications applications. They interface network devices such as a switch, router, media converter, etc. to a fiber optic or copper networking cable. They support various data rate speeds, typically up to 1 Gbps, and can be used for both telecommunication and data communications applications. SFP Plus is an enhanced version of the SFP that supports data rates up to 10 Gbps. It is a popular choice for network and storage system applications due to its higher bandwidth capabilities over its predecessor. Select the next option. Simplex refers to a single directional communication channel. Simplex transceivers can send data in only one direction, either transmitting or receiving, but not both. Simplex transceivers only have one connector slot for either sending or receiving signals. Simplex fiber setups are commonly used in applications where only one-way data transfer is required, like certain types of broadcast or monitoring systems. Insert each connector end into a local area network tester tool to verify that all the right wires have established proper contact with the connector pins. This is typically confirmed by seeing all 8 LED lights of the local area network tester tool lighting up. Your cable is now ready to connect two devices together in a network. Hold the connector and pull the cable gently just to confirm the wires are held tightly onto the connector. Repeat the steps for the other end of the cable. Duplex transceivers can send data in two directions simultaneously. They support bidirectional communication, which means they can transmit and receive data at the same time. Therefore, we need to have at least a pair of cables connecting two devices. For example, if device A is connected to device B, the fiber cable used to send a signal from device A is the one that device B will also use to receive it. Duplex transceivers have two slots, one for receiving and another for sending signals. Equipment designed to be used by duplex transceivers only uses one port for a single connection. In duplex fiber applications, each fiber connects the transmitter from one end and another for the receiver. The role of polarity is to make sure that this connection is maintained so data can be efficiently transmitted. Insert each connector end into a local area network tester tool to verify that all the right wires have established proper contact with the connector pins. This is typically confirmed by seeing all 8 LED lights of the local area network tester tool lighting up. Your cable is now ready to connect two devices together in a network. Hold the connector and pull the cable gently just to confirm the wires are held tightly onto the connector. Repeat the steps for the other end of the cable.